So let's start by writing a service definition that runs PostgreSQL in a fully isolated container. We configure essential environment variables like the username, password, and database name directly in the Docker setup. Now we're going to need a Postgres database in this project to store the product data so that we can select and actually then place in a shopping cart. I'm going to define this above our Redis service. So this is the name of the service, Postgres. We'll use this name to reference the container from the other services. Feel free to use whatever the latest version of the Postgres image is, but in this course I'm going to be using 17.4. That's the latest as of recording. I'm also using the Alpine image. So Alpine images are smaller and tend to be faster, ideal for development environments. So let's give the container a name, a custom name, instead of a random one, and this is useful for easier identification and debugging. So we're going to try and ensure that the container will restart automatically if it stops unexpectedly or when Docker is restarted. So this can be good for dev environments and production-like behavior. Now, if you are new to Postgres, do take a look through the Docker page to familiarize yourself with some of the setup environment variables that are required in order to start the Postgres service in the container. So what we're going to do here is set up some environment variables inside the container. So these are used by PostgreSQL to initialize the database. So we're going to need a username or a Postgres user. So we'll create a user called Postgres. We'll create a password, Postgres. And then in addition to that, we'll set up an initial database. So this creates a database named inventory. Now this configuration is intentionally simplified for education purposes. The database credentials here are insecure and should never be used in production. So always avoid hard coding credentials in Docker Compose files. Because the container is isolated by default, we're going to need to open up ports so that we can access these services within the container. So here on the left-hand side, 5432 is the host port, the port on your machine outside the container. And then the right-hand side, we have 5432, that's the container's port. So the port PostgreSQL is listening on inside the container. The Postgres database uses port 5432 by default. So this mapping allows tools outside of Docker, like Django, to connect to the PostgreSQL database running inside the container. So I've gone ahead and removed all the containers and images from Docker desktop to start fresh. And now we simply need to run Docker Compose up with the build and the D flag. So the Docker Compose up starts your service as defined in our Docker Compose YAML file build. So this forces Docker to rebuild or build the images before starting the containers. So this can be useful when you're changing code dependencies or Docker files, and it ensures you're running the latest version of your app. And then finally, the D flag here, this runs the containers in detach mode, meaning they run in the background. So we won't see the logs here in our terminal, and therefore our terminal stays free to do other tasks. Now, once you have built the containers, you can just go ahead and further run Docker Compose up from this point onwards. But within this course, I will just continue using the same command every time we restart Docker. Now, there is a problem here, and I just wanted to emphasize that point. So if we do run Docker Compose up, we will see that the service isn't validating correctly. So it looks like we have an issue in our code, and this is just an indentation issue, a very common issue when creating these services. So the port just needs to be on the same level as the other options. Now the indication here was after the environments discussing or defining ports. So there had to be something around that space or before or after it potentially that was causing the problem. So let's go ahead now and start the service. It should go ahead and download the images if you haven't already downloaded them and start the containers. If we take a look at the containers, we can now see the inventory Postgres database. Now, if we inspect the logs, we can see and follow the setup or initialization stages. We can see here that Postgres tried to initialize, it's found that it's the first time it has been initialized. There is no existing data. So it goes through a process, and then eventually it will then restart the service and bring it up to live. And typically around here, where we've created some customizations, that's where you're potentially going to see any errors, if there are any. Remember, we did set up some environment variables, and we instructed Postgres to create a database on initialization. And we can see that has been confirmed right here. So the server started, and then we created the database. Now we can verify that by going into the exec, and then we can log into our Postgres database. So to do that, we use PSQL. That's the Postgres command line tool. And then the U flag, and define our user. And that's Postgres. That's what we've defined in our Docker file. So now we're logged in, we can use \L to list all of the databases we currently have on the system, and inventory is one of those. If you wanted to view all tables in an easy, simple list, we can use a select statement like this. This should return a list of all databases. Now, you might be wondering, why do you have a Postgres database? Well, the Postgres database is automatically created by PostgreSQL during installation and serves as a default administrative or maintenance database. This is important because imagine we only had the inventory database. We cannot delete that database unless we're actually connected to another database. So by having this administrative database called Postgres, it allows us to connect to the server when, for example, no other database exists yet. And it also allows us to perform other tasks like creating or dropping other databases and running management scripts. So although it's technically possible to delete it, it's not recommended. It's always useful to have one known safe admin database.